Hello students, welcome you once again to GK's maths classes. Today under this topic of 5 problem per session, we are going to do JEE mains questions on matrices and determinant. Already I have put 5 questions on matrix and determinant in the previous video where I will attach the link in the description box, and this is the extra 5 problems which I feel that will be beneficial to you. So can we make a beginning? Okay, this is the question. If a matrix A, which is given here, which is a 3 by 3 matrix, satisfies this equation for some real number alpha and beta, I am expected to find beta minus alpha. So a power 20, a power 19 and a. Okay. So I know what a is. So what I will do, as usual, I want to see what pattern it forms. So I will try to find what is my a square is. So what is my a square? 1 0 0 0 2 0 3 0 minus 1. This I will multiply it with 1 0 0 0 2 0 3 0 minus 1. So first row, first column, what exactly do you get? You will get 1, first row, first column, 1 into 1, 0 into 0, 3 into 0, 0. Now again this will be 0, then again it is 0. Now second row, first column, what do you get? You get 0. Second row, second column, I think it is 2 square. Okay, it's 4, but I'll write it as 2 square. Second row, third column will be 0. Now third row, first column will also be, third row, first column will be 3, I think it is 0. Third row, second column will be 0. Third row, third column will be 0, 0 and 1. So this is my a square. Sorry, this is my a square. So there's a, let's keep it as it is. Now let's try to find what is my a cube is. My a cube will be a square into a. What is a square? A square is 1 0 0 0 2 square 0 0 0 1 followed by, what is my a? A is 1 0 0 0 2 0 3 0 minus 1. Let's multiply this. First row, first column. I get 1 0. First row, third column will be 0. Second row, first column will be 0. Second row, second column. Second row, second column will be 2 cube. Second row, third column will be 0. Third row, first column will be 3. Correct? 0, 0, 3. Third row, second column will be 0. Third row, third column will be minus 1. So this is a cube. Okay. Now what I will do, I'll try to find what is my a power 4 is. Okay. When I do a power 4 is a cube into a. I will leave it to you. You will definitely get it as 1 0 0. You'll get 0 2 power 4 0 0 0 1. Okay. What will be my a power 5? My a power 5 will be, look at a cube, it is 1 0 0 0 2 power 5 0 3 0 minus 1. Now just look at all the odd even powers. Look at all the even powers. Okay, a square, you will have 2 square here, otherwise everything else remains the same. All other elements remains the same. For a power 4, it is 2 power 4, all other elements remains the same. So what will be a power 20? So a power 20 will be 1 0 0 0 2 power 20 0 0 0 and 1. Exciting. Correct? Now look at all the odd powers, right from a power 1 to a cube. to a power 5, everything remains the same. See, the pattern is the same except that you have 2 power n. Okay, so a power 19 will be, what will be that? 1 0 0 0 2 power 19 0 3 0 minus 1. So we got a pattern here, right? Now what I will do, I'll take the equation. What is the equation? A power 20. I will do it in the next pages. Okay. So what is my equation? A power 20 plus alpha a power 19 plus beta a, and it is given as 1 0 0 0 4 0 0 0 1. This is what is given. Now what is a power 20? It is 1 0 0 0 2 power 20 0, and then it is 0 0 1, which we have already done. You can go to the previous page and see. Plus alpha into, what is a power 19? A power 19, I'll multiply the alpha inside. A power 19 will be alpha 0 0 followed by 0 alpha into 2 power 19 0 followed by 3 alpha 0 3 alpha 0 minus alpha plus, what is beta into a? Beta into a will be beta 0 0 0 beta into 2, which is 2 beta, correct? 0, then this is 3 beta 0 and minus beta, correct, is equal to 1 0 0 0 4 0 0 0 1. Now if you simplify this, what exactly happens is, let's look at first row, first column element. What will be that? 1 plus alpha plus beta equal to 1. So from this it's very clear that alpha plus beta equal to 0. So you got one beautiful equation. It will be there. Now look at the all other elements. There is no use. I will look for the second row, second column. 2 power 20 plus alpha into 2 power 19 plus 2 beta equal to 4. 2 beta equal to 4. 2 power 20 alpha into 2 power 19, 2 beta equal to 4. So this is 2 power 20 plus alpha into 2 power 19 plus 2 into, beta is minus alpha, correct? You can call this as 2 square, because beta is minus alpha. This is the reason for this. Okay. Now what is common here? Alpha is common. What do I get? 2 power 19 minus 2 equal to 2 square minus 2 power 20. I'm taking this 2 power 20 that side. So what is alpha equal to? I'll take minus 2 outside. So you get 2 power 19 minus 2 divided by 2 power 19 minus 2. So they get cancelled. So alpha equal to minus 2. Once you get alpha as minus 2, what will be my beta? Beta is minus alpha, therefore beta will be 2. So once you get the value of alpha and beta, what is beta minus alpha? Beta is 2, alpha is minus 2, so the answer is 4. Isn't it lovely? All that you need to do is understand the pattern, how a square looks like, how a power 4 look like. Look at the pattern and generalize it to a power 20 and a power 19, and then the problem is very, very simple. I hope you understand this. Okay, let's go to the next question. This is a very, very simple question. The sum of symmetric matrix of order 3 with all entries from the set 0 to 9 is. So what is a symmetric matrix? Symmetric matrix is a matrix where A transpose is equal to A. If you get A transpose is equal to A, it's a symmetric matrix. Then you say A is symmetric. Of course, it has to be a square matrix. So what I will do, I'll take a symmetric matrix. Let me call this as X, Y, Z. Diagonal can be anything. X, Y, Z. Diagonal can be anything. Whereas if this is A, this must be A. Property of symmetry. This is B. This also must be B. If this is C, this has to be C. I hope you remember when you do symmetric matrix, your diagonal acts like a mirror. So they should be same. Correct? So how many elements are there? If you want to fill matrix A, you need 6 elements, right? One is X, A, B, C, Y, and Z. You need 6 elements to fill it. Each element can be filled in 10 ways, right? 0 to 10. 0 to 9 is 10 elements. Each element can be filled in 10 ways. Each element in 10 ways. Now, therefore, the number of skew-symmetric matrix, number of symmetric matrix of order 3 using what? Using 0 to 9 is, I have to fill X and I have to fill A and I have to fill B and I have to fill C and I have to fill Y and I have to fill Z. Since it is and, by multiplication law, you have to multiply it. So there will be totally 10 power 6 matrix. There will be 10 power 6 skew-symmetric matrix of order 3 by 3 using the elements 0 to 9. Nice problem, isn't it? Let's go to the next question. Now, how do I do the next question? It's very, very simple. A is a 3 by 3 matrix containing real numbers, and you have been given 1, 2, 3 equations. Okay? First equation, second equation, and third equation, and then you have to use this to find the value of X, Y, and Z. I want to find X, Y, and Z. I want to find the matrix. Okay. As what actually here the question is, the system of equation has what type of solution? Whether it has a unique solution, or it has infinite solution, or it has no solution. This is what he is asking you to find. So I didn't complete the question. So I want to know whether this system of equation have unique solution or infinite solution or no solution. Let us see. Since A is a 3 by 3 matrix, I will take A as x1, y1, z1, followed by x2, y2, z2, and x3, y3, z3. Okay. Now what is given to you? It is given that A into 101 equal to 202. Correct? Equal to 202. This is the first equation given. Now what is A? A is x1, y1, z1, x2, y2, z2, x3, y3, z3, followed by 101 equal to 202. Now multiply. First row, first column. What do you get? First row, first column. It will be x1 plus z1, correct? Because y1 will be 0. y1 into 0, 0. Then x2 plus z2. Then you have x3 plus z3 equal to 202. So by equating, you get x1 plus z1 equal to 2 and x2 plus z2 equal to 0, and you have x3 plus z3 equal to 2. So I have got 3 equations. So let it be there. So I made use of this. It's over. It's done. I'm done with it. I'll just rub this off. I don't need it now. Now I'll go to the next equation. What is the next equation? My next equation is a into minus 1, 0, 1 equal to minus 4, 0, 1. Minus 4, 0, 1. 0, 4. I'm sorry. 0, 4. Now what is A? A is x1, y1, z1, x2, y2, z2, x3, y3, z3 multiplied by minus 1, 0, 1 equal to minus 4, 0, 4. Now first row, first column, as usual use matrix multiplication. Minus x1 plus z1, then minus x2 plus z2, then minus x3 plus z3 into minus 1, equal to minus 4, 0, 4. Normal multiplication. So now what do you do? Minus x1 plus z1 equal to minus 4, minus x2 plus z2 equal to 0, and minus x3 plus z3 equal to 4. I hope it's correct. Okay, minus 1, 0, 4. Minus x1 plus z1 equal to minus 4 it is, and then minus x2 plus z2 equal to 0, and minus x3 plus z3 equal to 4. Okay, this is a third set of equation. This is the first set of equation. This is the first set and this is the third set. Now let me make use of the last set of equation. What is that? I have a into 0, 1, 0 equal to 0, 2, 0. The third set of equation. Now what is this actually? This is x1, y1, z1, x2, y2, z2, x3, y3, z3 equal to into 0, 1, 0 equal to 0, 2, 0. Now first row, first column, you automatically get y1, and then you get y2, and then you get y3 when you may do matrix multiplication, which is equal to 0, 2, 0. This implies y1 is 2, y2 is 2, so y1 is 0, y2 is 2, and y3 is 0. Correct? Now that you've got this y1, you have got y1 is 0, y2 is 2, and z1 is 3. Now I have to find the value of x1 and z1. So what I will do, I'll take x1 plus z1 equal to 2 from here, and minus x1 plus z1 equal to minus 4. So you add them, you get 2z1 equal to minus 2, z1 equal to minus 1. Once you get z1 is minus 1, you can substitute here x1 minus 1 equal to 2, therefore x1 equal to 3. So I got the value of x1, I got the value of y1, I got the value of z1. I have y2. Now how do I find y3 and z3? Correct? To find y3 and z3, what I will do is, just a second, I have to go to y2 is formed. So now take these two equations. Okay, take minus x3 plus z3 equal to 4, and x3 plus z3 equal to 2. Correct? So I take this equation and I take this equation, and I get 2z3 equal to 6, z3 equal to 3. If Z3 is 3, what do I get? I get x3 plus 3 equal to 2. So x3 equal to minus 1. Okay. Now that I've got all the values of x1, y1, z1, x2, y2, z2, x3, y3, z3, I get the matrix A. So what is my matrix A? I'm getting my matrix A as, I don't want to go to the page, so it will be x1, y1, z1, x2, y2, z2, x3, y3, z3. This is my matrix. So we'll just check it. See, x1 is 3, y1 is 0, and z1 is minus 1. That is what I got here. So similarly, you can cross check. Now I want to find a minus 3i. A minus 3i. What is that? 3, 0, minus 1, 0, 2, 0, minus 1, 0, 3, minus 3i. What is that? 3, 0, 0, 0, 3, 0, 0, 0, 3. When we subtract this, I get 3 minus 3 is 0. You get 0, minus 1, 0, minus 1, 0, minus 1, 0, 0 into x, y, z. I'm talking about a minus 3i into x, y, z equal to 1, 2, 3. Now how do I multiply first row, first column? Minus z, correct? Then what do I get? Minus y. Then I get minus x equal to 1, 2 and 3. So clearly z equal to 1, y equal to minus, z equal to minus 1, y equal to minus 2 and x equal to minus 3. Very simple question, but it's a process, So you have to understand the process, go step by step, then solve the linear equation, you automatically get the answer. So if you use all the conditions that is given, that is the essence of all problems, use all the conditions that is given effectively, you will get the answer. Okay. Now let's go to this nice problem. Let A equal to x, y, z, y, z, x and z, x, y. Now here what you are supposed to do is, you are asked to find the value. What value you want to find? You are asked to find the value of x cube plus y cube plus z cube. And what is given to you? That a square equal to I and xyz equal to 2. So first let me make use of a square equal to I. It's very clearly given in the question that a square equal to I. So what is a square? X, y, z, x, y, z, x, z, x, y into x, y, z, y, z, x, z, x, y equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Now multiply first row, first column. I get x square plus y square plus z square, which you should know, matrix multiplication. First row, second column. What is that? xy plus yz plus zx. Okay. Then first row, third column. I don't care. You don't have to do. So I don't want to do all this. Okay. I just need these two. If you want, you can complete it and see. There's no harm in it. But sometimes you should learn these shortcuts also. You don't have to complete the entire multiplication process, because this is what we require. What I require? From this you see x square plus y square plus z square equal to 1 and xy plus yz plus zx equal to 0. Okay. So even if you do this, you get xy plus yz plus zx. So it's a simple situation. So I got this. Now what I will do, I will find what is my x plus y plus z, the whole square is, which is x square plus y square plus z square plus 2 times xy plus yz plus zx. Now clearly x square plus y square plus z square is 1. and xy plus yz plus zx is 0. So I have got x plus y plus z whole square is 1. Since x plus y plus z is positive, we get x plus y plus z, the root will be only 1, it will not be plus or minus 1. Okay, that's another very important thing. Now, you also know from algebra that x cube plus y cube plus z cube minus 3xyz equal to x square is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus z. Very famous identity. Okay. Now from this you have x cube plus y cube plus z cube minus 6y, xyz is 2. So 3 into 2 is 6 equal to, and you know x plus y plus z is 1. And x square plus y square plus z square is also 1. And minus xy plus yz plus zx is 0. So I get x cube plus y cube plus z cube minus 6 is equal to 1. Therefore, x cube plus y cube plus z cube equal to 7. Very beautiful sum. Nothing we did. We just did matrix multiplication and simply solved some algebraic equation. Nothing else. Okay. Very, very simple question. But you need to think. You can't just do these problems just like that. Now, let's go to the next question. This is a very, very nice problem. Let us see how it works. Now, in this problem, what I will do, I will take A minus 2A transpose as P, and here I will take my Q as 2A minus A transpose. It doesn't matter which one you take it as P and which one you take it as Q. I have taken it as P and Q. If you want, you can take this as P and this as Q. There is no hassle. Then what I do, I try to find Q transpose. Q transpose is 2A transpose minus A. So how did I get this? I made use of two results here. That is A minus B transpose is A transpose minus B transpose, and I also use the fact that A transpose of transpose is A. So using that, I get this result. Now if you notice this carefully, this is nothing but minus P. Correct? It's nothing but minus P. Now I take determinant on both sides. Determinant of Q transpose is same as determinant of Q, which is same as determinant of minus P. So here I am making use of the fact that determinant of A transpose is determinant of A. Now what I do, I can write this as minus 1 to the power of 3 determinant of P. What result I use? Determinant of Ka is K power n determinant of A. So determinant of Q is nothing but minus of determinant P. Minus of determinant of P. Now I square both sides, which is nothing but determinant of P the whole square. Okay? Determinant of P the whole square. Now what happens? I will go to this determinant of P. I go to determinant of what is given in the question. This is adjoint of Q into adjoint of P equal to 2 power 8. Adjoint of Q into adjoint of P equal to 2 power 8. But you also know this is nothing but adjoint of Q into adjoint of P equal to 2 power 8, because you know determinant of AB is determinant A into determinant B. Okay, so determinant of AB is determinant A into determinant B. Now what I do, this is nothing but determinant of Q whole square, this is determinant of P whole square. What result is it? Determinant of adjoint of A is determinant A to the power of n minus 1. I am using that result. So now Q square is P square. So determinant of P whole power 4 equal to 2 power 8. Therefore determinant of P is nothing but 2 square. Okay. Now what I do, I want to know what is my determinant of P is, right? So I try to find out what is my A minus 2A transposes. What is my A? My A is 1, 2 alpha, 1, 0, 1, 0, 1, 2 minus, what is 2A transpose? 2A transpose will be 2, 2, 0. Okay, it will be 2, 2, 0, and then 4, 0, 2, 2 alpha, 2 and 4. 2 alpha, 2 and 4. Now when you subtract, I am getting minus 1, I get 0, I get alpha, minus 3, 0, minus 1, minus 2 alpha, minus 1, minus 2. Correct? So minus 1, 0 alpha, minus 3, 0, minus 1, minus 2 alpha. Okay, we got this. Now I want to find determinant of A minus 2A transpose. What is that? Minus 1, 0 alpha, minus 3, 0, minus 1, minus 2 alpha, minus 1, minus 2. Always remember to expand the determinant where there are maximum number of zeros. So in column 2 I have maximum zeros. So I will expand with respect to column 2. Plus minus plus minus plus minus plus minus. So cofactor. So it is minus of minus 1. Leave that row, leave that column. What do I get? 1 plus 3 alpha equal to 4. That's what we have, right? So you get 1 plus 3 alpha equal to 4. Therefore alpha equal to 1. So once you get alpha equal to 1, substitute here. So what is A equal to? 1, 2, 1, 1, 0, 1, 0, 1, 2. Find determinant of A. What is determinant of A? 1 into minus 1, minus 2 into 2, plus 1 into 1. So my determinant value is minus 4. So what is determinant of A whole square? It is nothing but 16. Correct? So very simple, but you need to think and do these problems. Okay? So I hope you understand these problems. I have done 5 questions today. We'll continue the session of 5 questions as problem in the next video also. I hope you learned something in this. Thank you very much. Kindly subscribe to my channel and click the bell icon for notifications. Have a lovely day. See you in the next video. Bye bye.